boys and girls, I figured I would go ahead and start documenting my calls that I run for a couple of the AC companies I work for part-time to help supplement this wonderful job I have at Lorenzo in my HVAC program. So I'm going to be taking you guys along on the calls that I run on the weekends, the services I do, and possible installs here in the near future. That being said, we're just going to do a quick rundown on what I'm doing today. Today I am doing a maintenance on a sizable home. It's got two systems, a master unit and a main unit. We have a complaint that the master unit is not keeping up or not functioning correctly, so we're going to take a look at that and make sure we identify what kind of issues we could be having there. The house is 2 years old, so the equipment is 2 years old. We're going to go ahead and establish where everything is, and then we're going to get started on this. But before we do that, we're going to take a look at the tools we're going to be using today. So we're going to be using our maintenance service bag here, my MB4B, or sorry, MB4B Vita Pro Pack gator mouth bag here. It's got everything I need in there to complete this today. My drill, my hand tools, my service probes, my meter, my thermometer, safety glasses, because that's important, gloves, cleaning tools, utensils, anything electrical I may need. So it's going to be everything we got to get going today for. We're going to be using a wet vac to clean the drain lines out today, which I have a feeling that's going to be probably the issue with the master unit. And then we got our maintenance box. And in our maintenance box today, we got some cleaning rags to take care of some stuff. We have some gel tabs for the drain pans themselves on the inside, some cleaning solution for the evaporator coil, some further cleaning solution for the drain pan and the drain line, my flush jug here with a cleaning brush, and my rubber gloves I'll be wearing when I'm working with the chemicals. So again, this is just a standard maintenance. They moved into this house recently, so they are wanting to know what the overall status of the equipment is, how it looks, it's basically just an inspection plus a maintenance. So they want to know what the installation looks like. We're going to be taking a look at filters and all that good stuff. So I'm going to go ahead and get my tools ready and set up, and I'll see you at the unit. All right, so I'm going to run down real quick. I got my bag on me here. I'm getting ready to go approach the equipment for the main house. We're going to start there since we don't seem to have any problems, and we're just going to go through an overall check on that. The reason I like these boxes, these pack out boxes in general, is because, including this wet vac here, is because they lock together and they make things, as far as transportation, much easier. So I got a decent battery there, and I got a backup battery for when I need it. So we're going to go ahead and do this. All right, and now I can carry my bag and my cleaning supplies and all that good stuff all in one go. We're gonna go ahead and take a look at the outdoor unit. Now, I don't really need any of the cleaning supplies for the outdoor system. We're just gonna be spraying out the coil and all that good stuff. So for now, I can drop off my maintenance box for the indoor unit. Main unit is in the garage in the attic here, so take a look at that when we get to it. But like I have stated several times, I like to start my maintenances at the outdoor system. And I like to start my maintenances at the outdoor system because if I happen to run into any issues checking the refrigeration cycle or any of the electrical measurements, then I know that I will not have to waste any time cleaning the air handler, especially if I happen to have refrigeration issues. Like I was saying, if I have those and it turns out that I have a refrigerant leak, what's the point in cleaning the evaporator coil? There's a good chance that the evaporator coil is our problem. So all right, I can identify here that we got a drain line. That's our primary for the main system. It's got a good drip to it, so it's cleaning or draining. So what I like to do when I start my maintenances is go ahead and hook my shop vac up to the drain line. You can already see there's some slime coming out of that thing, so it definitely needs a good cleaning. Normally I would kick this on, let it operate while I'm doing all my checks, but I'm gonna go ahead and save that for when I go upstairs in the attic to check the air handler, so that way I don't have to fight the noise when I'm talking to you guys. All right, so we're gonna go ahead and start with the Hooking up all my refrigeration equipment, or my testers for my refrigeration stuff. Get my drill out here. We're gonna go ahead and take my clamps, probes. Looks like we're going to need a lock and cap key of some kind. Oh, nope, they weren't really on there well. These are plastic. Normally they're metal. That's an Allen, so wonderful. Looks like that might actually fit though. My service wrench. So I like these Vito bags. It's that nice, awesome hanger up there. I can hang it right on the unit in case I'm working on the system. Oh, look at that. Sure enough. Perfect. Now, we want to make sure we put these in a spot we don't lose them because they need to go back on the system. All right, we're going to go ahead and put our probes on and our temperature clamps. Now, these work off of a wireless system that connects to my phone where I can read all my measurements. We got our suction side identified by our blue there. You can also see here it says suction. So we're going to go ahead and put that on. We're going to make sure that we pull back on the probe so that way the depressor does not make contact with the Schrader core until I'm ready for it, so we don't lose a bunch of refrigerant. And you see I had a little bit of a spurt, but nothing too bad. Now it's usually the liquid line that's going to give us the most problems here, so hopefully we can do this quickly and avoid any blowback. All right, just a little bit. And that's pretty normal, you know, even when you're putting on low loss fittings, that can happen. There are these depressing tools that I plan on getting here in the near future that will allow me to put that on without depressing the Schrader core until I want to. So, all right, so we got our liquid line tip clamp, our suction line tip clamp, our low pressure and our high pressure measurement tools hooked up. We're gonna go ahead and bust out the multimeter here so we can check our electrical functions. If you can't tell, I'm a big fan of Fieldpiece. I think they offer some of the best products for HVAC, service, maintenance, and installation. And highly recommend it. All right. Got our service panel off there. Again, gonna put my screws somewhere where I'm not gonna lose them. And the reason I like this drill is my maintenance drill. It's not very powerful, but it's good for maintenance. I got a nice little magnetic strip there to kind of hold things so I don't lose them. Should not be losing panel screws. You should not be losing refrigerant caps. All right, so this is a pretty standard system here. It's a 24 volt based contactor. We got a dual run capacitor for the compressor and the fan. So we're gonna go ahead and shut the system off. The reason I'm gonna go ahead and shut this, actually, you know what? I'm going to check the refrigerant pressures first because I've had this system running for a good little amount of time since I've got here, which is going to give me a good accurate reading on my refrigerant cycle. And because we'll have a good accurate refrigerant cycle, I want to take a look at that now. Typically when I show up and I first kick everything on, I start with the electrical, but that's because the system hasn't been running very long. All right, perfect. So we'll hook the manometer up when we get up there. We got R410A refrigerant. Ruh-roh. Something's not quite right. Oh, there we go on our subcoolant. Make sure it's making good contact and reading the temperature on that good. All right. So we have a suction pressure of 129.5, a liquid pressure of 307. We got a 44 degree saturation on our evaporator coil, a 97 degree saturation temperature on our exit temp. We're getting an okay superheat. We're getting a low subcool. I'm going to take a wild guess because we have the Florida sun up there beating down on this unit, producing a lot of ambient heat on the system, that might be an indication as to why our subcoolant is not so hot. I also don't think this is quite reading right, simply because that does not feel like it's 94 degrees in itself. Alright, either way, I'm happy with my saturation temperature. Both of my coil pressures look good. My superheat's pretty good. we're getting a good, you know, I like to see it between 14 and 20, but with the temperatures we have inside, the fact that I haven't changed any filtration yet, and all that good stuff, that I'm not too worried about those numbers. They look all right. Subcoolant, like I said, is a little low, but I feel like it's got a lot to do with our sun beating down here on the unit, producing ambient temperature a little bit higher than what we would hope for. So we'll verify everything when we check the air handler and the temperature split or the temperature differential on the air handler itself. So we're going to go ahead and move on to the electrical checks for the system now. So this is our disconnect for the main system. Go ahead and pull that out, de-energize the unit so we can safely work on it. I'm going to grab a set of electrician pliers here real quick so I can de-energize my run capacitor. Alright, it's always a good idea to, when you're removing your spaded wire connections for the dual run capacitor, or if you're working with a single run capacitor, to try and use some kind of leverage to pull them off. You want to attach to the actual spade and use the capacitor itself to pry it off. I mean, you can go and pull on the wires to try and get things off, but you're going to run the risk of pulling the wire right out of the spade, and then you have an extra repair to make that is completely avoidable. So I recommend taking a pair of pliers, applying some leverage to the system or the capacitor, and popping those things right off. They shouldn't give you any trouble. So now we've isolated the dual run capacitor because that is the only way for us to properly take the microfarad measurements and read the capacitance of that capacitor. If we leave the system, the capacitor, hooked up to its electrical connections, then we're dealing with resistance through our windings and everything of the motor, so we're going to get inaccurate readings or no readings at all. So we're going to go ahead and switch our multimeter over here. This is the SC480 field piece wireless meter. I can also, again, hook it up to my phone if I want to record some measurements. I'm going to go ahead and go over to the feature for microfarads. We always start our microfarad check with our common, which is going to be on the left side here. Common can have 3 spades or 4 spades. Your compressor side usually has, which will be labeled Herm, 3 spades, and our fan side of the capacitor will either have 2 spades or 1 spade connections. So we always have one of our leads hooked up to common when we're checking the capacitance to capacitor. Now we're going to take the other side here. We're going to start with the compressor side. So this is a 45 plus 75 microfarad capacitor, 370 volt. All right, so we're reading a plus or minus 10% on that number if we are reading good, and we are reading 43.9, almost 44 microfarads. So that is telling me that capacitance for the compressor is good. We'll go ahead and move on to the fan. We're looking for 7.5. We got 6.97. So I'm gonna say that is also within range of the rating for that capacitor. And that right there is it as far as checking the capacitance on the capacitor. No problem. Our orange wire here is going to be going to our compressor. Our brown wire should be our fan side. Our red wire is going to the contactor, so that'll be my common. And then on top of that, we have another wire, which should be the other half of the high voltage for our fan, and we will put that on the common side as well. So the next measurement I'm going to want to take here is going to be my high voltage reading and my inrush amp draw for the compressor. So I'm going to pop these on there so we can get a nice reading on the high voltage. Well, I mean, we can take a look at the low voltage real quick while we're at it before we start everything up. 27.1 volts. So that tells me the transformer is wired properly and it's producing the right amount of low voltage for our contactor. I know we always talk in terms of 24 volts, but realistically you want to see a number higher than 24 volts. 26, 27 is a good number. That's going to ensure that that contactor is making a good contact when it's pulled in. It's got a strong connection. Now we can look at this contactor and see that it is a single pole contactor, meaning we have high voltage going through one side of the system at all times, and then when the call for cool comes in, we put in the other 120 volts to create the 240. So we're going to go ahead and find our compressor wire here for our run. We're going to hook up to that. I'm going to set my meter for inrush, meaning that it's going to collect the highest reading when the compressor goes to start. Now again, the capacitor, its job is to help with the initial torque of the motors, the fan, and the compressor. Our compressor being the largest, which is why we have a higher reading on the microfarads for 45, and on the fan side we have 7.5. So we already identified that that's good. So we're going to take a look and see what this thing starts up on amp draw. Now the number we're wanting to compare that to is the lock rotor amps. On our Trane units here, your nameplate is always on the corner opposite of your electrical panels. So let's take a look at that. And we have, it's a 2021 system, 410A. We're looking for about 8 degrees of subcool. Typically that's a plus or minus 3 ordeal, but not on this one. It's looking for 8, which again, we're getting beat down by the sun here. We're getting a lot of extra ambient heat, so not too worried about that number. We'll take a look at the split to make sure we're cooling properly. But compressor motor, our RLA is 18.5. Our outdoor fan motor, FLA, is 0.9. So those are the run ratings we're going to want to check when we're taking amp draws. Now on our start, we're looking for our LRA. So we have a lock rotor amp draw here. And this is indicating that this system, if it reaches 124 amps on start, we'll lock that compressor up. We're going to have a serious issue, and we should try and find a fix for that if that's the case. But we're looking for a number that's well below 124, so let's go ahead and see what we get. All right, so we got a little chunky start there. Over limit, so that's not good. So we're gonna want to recommend a hard start kit for this system at this point. Something that's going to help with that initial torque on the unit and prevent any starting issues in the future. So that's what I'm going to recommend for this system. All right, but we're going to go ahead and take our run amp draw, our RLA. Let's see if we have any issues there. So we were looking for, I think, rating 18.5. You want to see about 60 to 70% of that actual reading when you're checking the run. So we have 11.9, a little over 12. It's bouncing back and forth. So I'm going to go ahead and say that is within range of what I want to see for a healthy compressor on run. Now we're going to go ahead and check our FLA. 0.94. Let's take a look at that rating again, because that sounds like it's pretty close to what it actually was. 0.93, so we're right there. So something we're going to do, which would be a part of our maintenance either way, because we're reading that actual amp draw. And unlike the compressor amp draw, you can read up until that fan amp rating and not really have any issues. But once you start to creep over that rating, we're not looking too hot. So we're right there. Something I'm going to want to do here is go ahead and wash this coil out, and that'll give me an idea if we have any changes on those amp readings with a cleaner coil. Now again, that's part of your maintenance, so it's not a big deal. It's something we should be doing either way. So we're going to go ahead and get to that process. I'm going to go ahead and get the top off, get my water hose set up. So I'll see you back here in a minute. All right, so we're back. I got my system de-energized, so I don't have any issues with that, because obviously I needed to de-energize to take off that fan top. Got the fan motor pulled. Got my screw set aside so I don't lose those. I got my water hose here, and we're gonna go ahead and spray the coil from the inside out. That is the best way to clean our coil. So we'll get a little over here. We don't want too high a pressure because we don't want to damage the coil fins themselves. We're going to see if we get a change in amp draws on our fan. Maybe a better subcooling while we're at it. We got a little dirt coming out, nothing too crazy. And you just give it a good wash inside out. Yeah, I'm getting some good dirt off of there, off the bottom for sure. So that way we can make sure the system can breathe properly and reject the heat efficiently, giving us our optimal cooling capacity. You don't need a lot of water pressure to do this, especially with the fine fin coils. They come nice and clean pretty quickly. Now, if this coil were to be impacted, it could be a possibility that we would have to use some chemical to clean it, some condenser coil cleaner to break down growth. But if that were the case, it would be a little bit more than a preventative maintenance. Preventative maintenance is something that we do to maintain equipment that is functional. If we come across anything that is outside of the realm of functional or a much deeper process to take care of, then we're talking about a recommendation and another call. A service call for a deeper clean is an additional charge for that kind of stuff, but your maintenance is pretty straightforward. You should always be doing a quick condenser coil clean and taking care of that to prevent any cooling issues. I'm gonna step on the other side here so I don't get water all over me. This water hose, thankfully, was just long enough to get where I needed to get to clean this. So again, I like these spine fin coils personally. I think they're great at heat rejection. I think they're great when you clean them. Not a lot of wrongs you can do as long as you're not using too much water pressure. You should be okay. Alright. So I'm going to go ahead and button this thing back up, and we will recheck some amp draws, at least on our fan motor. I already let the customer know that the amp draw on start for our compressor is not looking too good, and I would recommend a hard start kit for that. So they already said that that sounds good, so we'll take care of that another time. But for now, we're gonna go ahead and check our fan amps. So go ahead and pop this sucker back. All right, I'm gonna button this thing up, and I'll see you back here in a few. All right, so I went ahead and took some time to change the filters. My battery was getting a little low on this thing. I hadn't quite charged it properly, but changed the filters for the main system. I had a filter in each bedroom, in their gym, and then in the hallway for the main. So they were all pretty rough. Went ahead and swapped those out. We're gonna make our way to the air handler now. This thing's done. They approved the hard start kit, so I'll get out here in the near future and replace that. Gonna go ahead and hit the vacuum one more time. So I'll see you up there. All right, so we're gonna go ahead and head up to the main house air handler here in the attic. I have the drain line being vacuumed currently. So we're gonna go ahead and flush that while it's running. You can hear it pulling there. So we like to flush the drain line with hot water while we're vacuuming. That gives us our best chance at a decent clean during a maintenance. Alright. Be as careful as you can. Normally I have a quick pour funnel on here, but I've misplaced it, so I need to get me another one. Alright. So I'm going to go ahead and shut off the vacuum because I only got so much battery left. I need to clean the other system out for sure. We're getting pretty good suction on this, so finish that off. I'll add some drain pan treatment to the system, and we'll check out the pan next. All right, and we're back. So drain line definitely has some stuff in it. It was not too good for the drain line itself, so we got all that junk out. I'm gonna go ahead and check my TD. That is my temperature differential between what is coming in the system, which is our return side, and what's coming out our system. This is supply side. This definitely could have been installed a little bit better. The way the supply trunk or the supply plenum comes off like that and then has the main trunk going out that way, could have definitely been positioned a little bit better, especially with the amount of room we have up here. But go ahead and try and reuse the same temperature probe spot that's been used. We're going to set that thing to take a reading. Well, I'm gonna go ahead and set up everything else I need here. So I'm gonna get my coil cleaner, my brush if I need it for the pan, a couple pan tabs, and my drain pan treatment. I'll go ahead and get some gloves on here. I'm gonna go ahead and set up my extra light. We got light up here, but it's not great, and you can see my shadow, so see if we can make this a little bit better. Oh, look at that. So I'm going to go ahead and position that sucker up here. Cool. I love this light. Battery powered. Charges quick. It's got a glow in the dark feature so you don't lose it in the attic if it dies. Alright. We're gonna go ahead and check the static for the system while we're up here. So while I wait on these, I'm gonna save some camera battery. I mean, that looks pretty good. 70. It's kind of holding, so move on to our next temperature here using another spot that's already been used. I'm going to go ahead and throw a probe, manometer probe, in for my manometer. In the direction of the airflow, or the best I can. Alright. Go ahead and throw the supply one in. There's a spot right here. I need to get some new tubes for this. I don't quite like these ones. All right. Perfect. So we got a temperature split between what's coming in and what's coming out of 21 degrees, which is not bad. We like to see 20 for optimal cooling. A little above that's not terrible, but you don't want to get into 22, 23, 24 degree split, because then you're going to have humidity issues. So let's go ahead and take a quick measurement of the manometer. It's pretty high static on the supply. I have a feeling that was probably not. Yeah, see, we need to zero that thing out. So it's reading 6.9 and there's nothing even going on. So we need to read that. 0.8 on our, there we go. 0.8 on our return though is fantastic. So we got adequate airflow in our return. Go ahead. Back in there now. Let's see what we got. Much better. 0.09. We'll climb a little bit. I'll give it a second, but I don't believe that's going to be getting much higher than 0.2, which phenomenal. So we have excellent static pressure on our ductwork. 0.2. We don't want to see that collective total over like a 0.9, so excellent. Ductwork's in good health. I'm gonna go ahead and get this thing opened up. You can see this is a Trane TM9. It's a composite plastic positive pressure cabinet, meaning we have the blower at the bottom, coil at the top, air's pushing through it. If you feel around here, there's actually air coming out these gaps, which it's designed to do, so do not panic. That's all good and fun. We have a primary switch, a secondary switch, which we will make sure we test before we leave the attic. And yeah, everything's looking pretty good on this install. I don't really like the positioning of the plenums, but we have good static, so who am I to complain at this point? So all right, we're gonna go ahead and open up the cabinet. There's Phillips screws. Make sure we do not lose these. Make sure we do not over tighten them. That's why I like my maintenance drill here. It's not that powerful, so I shouldn't be able to crack all this stuff here. So we're gonna go ahead and pause this and open everything open up. I'm gonna go ahead and test the flow switch, which should kick this into a time delay if it works properly, giving me about 5 minutes to work on this thing while it's opened up. I don't normally remove the panels on a system that is operational if it's a standard traditional unit, because it's usually a negative pressure, right? So our blower motor is at the top versus a positive pressure at the bottom, meaning that it is sucking in a lot of it. It's sucking in all its air through the cabinet, meaning that it can pull off insulation from the door that you remove, etc. So you want to be careful when you're doing that on a negative pressure cabinet. But this being positive pressure, this being composite plastic, nice thick, molded in installation, molded in pans, I don't really have anything to pull off, so it's not so bad to pop this off while it's operational. But I'm gonna go ahead and test the switch and see if we get it to shut down. Perfect. SRT switch tripped, meaning that it's wired properly and operation's done. So we should have about 5 minutes before this thing kicks back on. We're gonna go ahead and inspect the coil. Yeah, light dirt, light buildup, nothing unexpected. They had cheap filters in there, so heating coil looks good. That was already tested. Oh, it's already kicking off. Status fan on. Okay, we'll go ahead and kick that back off one more time. But pan itself looks excellent. No buildup, no growth, no nastiness. So we're just going to treat that pan, treat this coil. Blower looks pretty good, and I don't need to test the heat. They did that during the inspection for the home, so we're just going to go ahead and stick with the cooling side of things today. But normally on your maintenance, you would kick on the heater, check your amp draws, make sure it's matching the kilowatts you have for the heater. 20 amp for 5 kilowatt, 40 amp for 10 kilowatt, and 60 for a 15 kilowatt. So I'm going to go ahead and kick this off one more time, make sure the fan's not blowing, so when I'm chemically treating this, I'm not getting anything blown back on me. So let's go ahead and do that. Kicked it off. We're gonna go ahead and get our evap foam, no rinse. I like this. There's other cleaners you can use, but no rinse is the important information here. We're gonna coat this good. It's more of a deodorizer. It's also a growth inhibitor. So we're kind of disinfecting the coil, so to speak. This is not a lot of buildup on the coil, so I'm not too concerned with it. But we want to get all the parts of the coil that we can possibly reach nice and caked. I like to get these areas too, simply because keep some growth off there. We got our fan coming back on, so I'm going to go ahead and disable that one more time. All right, so there's not a lot to clean on this unit. It's in good shape. Drain line's clean, drain pan's clean for the most part. We're gonna go ahead and treat it though to keep it clean. So this is a, you can think of this as like a PAM, so kind of idea here, like PAM for the bottom of a pan, so when you're cooking nothing sticks. This is kind of the same idea. It also helps with bacteria growth, so you can hit the bottom of the coil with it, coat the pan, and it should help inhibit growth. But we're also going to do one more thing just to be safe here, and that is add some algicide tabs to the unit. These ones are good for 3 months per tab. I like to stack them up like so, and that should give us a good 6 months worth of treatment on the drain. We're going to stick that in there, stack them on each other, put it in a good position, and those will deteriorate over time, adding treatment to our pan. So that's pretty much it for the cleaning aspect of this. One thing we need to do, which I'll do real quick, once this thing gets up and operational again, we're going to check the amp draw on our blower motor real quick. So I will be back. All right, so our fan's ramping up now. We're in cooling stage 1. I have a 5 amp draw rating on my FL amps for the blower. I'm currently drawing 0.9 on cooling stage 1 operation. So all right, so we have wrapped up today's job. 2-system maintenance. Master bedroom had a problem. My initial assessment on the problem was that it sounded like there was probably a clogged drain line. I videoed and recorded the main maintenance for the big system, all the steps I like to take, excluding the electric heat test, which had already been done by the home inspection beforehand. So I didn't feel the need to kick it on now, but they just wanted to make sure the system was clean and operated properly as far as cooling went. Everything went well with the main system. Outside of the start amps, we had an over limit, so recommended a hard start for it, and they approved that. On the second system in the master unit, it was actually what I initially assessed, a drain line issue, so lack of maintenance. The primary drain pan was filled pretty good with gunk and junk and slime and nastiness, and the drain line was just disgusting. So went ahead, flushed that several times, vacuumed it out, treated the line, put some line pan algicide tabs in there to help regulate that growth and prevent that from happening next time. Hopefully buy us some time till the next maintenance. That being said, the operations on the equipment were good outside of, again, the starting of that compressor. Our lock rotor amps were indeed met, so I did recommend yet again another hard start kit for that system, which they approved. So I'll get those two pieces in there shortly, and that should take care of that. But in total on this job, outside of buying parts, the actual cost to the homeowner for the two system maintenance, the filters for the house, I gave them 2 filters for each one they had. They had over 5, so I think it was 10 or 12 total filters. And the 2 hard start kits, which I gave them a deal on, I made about $560 on this job. So lucrative business to be in, guys. I got there at 10 o'clock. It's 2 o'clock now. You know, I made sure I gave a very thorough inspection on this. New home to them, so wanted to make sure that if there were any issues, we were going to be able to identify them. And yeah, so they're very happy with everything. Everything's very clean. Everything's running very efficiently now. And we'll take care of those starting amps on the compressor the next week, and they'll be good to go. So I'll see them again in about 6 months. And that's it for